All right. Good afternoon, everyone. My name is Andrew Jenko. I'm a senior customer success engineer with ROCK Robotic, and I'm going to be hosting today's webinar about ROCK's new offering of photogrammetry. We are very excited about this new offering and very grateful for everyone who's taking the time to attend, give us feedback, and learn about this new offering, and really looking forward to taking that feedback and gradually over time improving it. So we're going to jump right in. I'm going to start with a presentation. And what we really want to get into as well is, the ROCK Photogrammetry offering is now possible because of the upgrade that has been made to the ROCK R3 Pro V2. So that's been a large amount of work put in by ROCK's development and engineering teams to improve the current R3 Pro offering in that V2. It's going to have four parts of it that we're really proud of moving the R3 Pro V2 forward. That's going to be enhanced corner accuracy, repeatability and overlap has been improved. There's improved colorization. And finally, there is going to be better data quality overall through this R3 Pro V2 LiDAR unit. If you do have an R3 Pro unit at this time and are interested in upgrading it, please reach out to the ROCK team, support@rockrobotic.com, to let us know about your interest. And then from there, we'll be able to provide you with further details about the upgrade process, cost, timeframe, so on and so forth. That's because the unit does have to be sent to the ROCK team to have the upgrades done to it. So if that's something you're interested in, just reach out to us and we'll get you squared away with that. So as I mentioned, there's 4 points that we're really focused on with the ROCK R3 Pro V2 offering. And the first is going to be the enhanced corner accuracy. So essentially, there have been improvements and advancements made in algorithms and firmware on the R3 Pro V2 units. Part of that is going to be the improvement related to capturing corners. So that is something that's really critical, not both with 3D models, but also as it relates to photogrammetry, is understanding accurately the location of those corners within your survey area. We have the repeatability and overlap that's been improved. Repeatable data is going to be paramount to obtaining a high accuracy final model and a photogrammetry ortho photo. And all that's been improved through the ROCK R3 Pro V2 offering. Our third point is that we've improved the colorization. So by improving the colorization, you now have the ability to visualize features with greater clarity. And then the fourth point associated is going to be the better data quality. Overall, the quality of data collected with the R3 Pro V2 has significantly improved. For those of you who attended last week's webinar where Harrison released and discussed the improvements, he showed how we saw a much smoother data and lower noise for the LiDAR data that was collected during the turns of the survey. In past, with the previous version of the R3 Pro, that data was a bit noisy. Now with the R3 Pro V2, we can see that the noise has been greatly reduced. And so now moving on to ROCK's customer success. So, what I want to focus on briefly before we dive into photogrammetry is that ROCK does have a dedicated customer success team. I'm a part of that, but we are a team that is going to focus on assisting you with your questions, issues, and comments as they come up. It's Vicky, Jared, and myself are the main CS members. I've included all of the main ways to get in contact with us via email, but also we have the ROCK Knowledge Base, we have the ROCK Academy, and we have ROCK Community. Those are 3 constant areas that we're adding information to or updating, or other users are posting resolutions to questions they've had. And also, we're going to start having regular webinars. So the goal of the customer success team is to make sure that you and your colleagues have confidence when using ROCK's hardware and software solutions, and are also aware of the resources that are available to you to get trained, answer your questions that may come up throughout your use. We follow a standard 9 to 5 East Coast time on Monday through Friday for things like chat availability, but depending upon who's working, you can get support outside of those hours. Also, if you are working in ROCK Desktop and you come across a processing issue, if you click on Help and Contact Support, you can then reach out to us via email, and it'll include information like your processing logs that can help us best diagnose your problem. So now that we've gotten into background of the customer success team, would like to start getting into the new photogrammetry option through the ROCK R3 Pro V2. So now it's with the R3 Pro V2, we have a photogrammetry solution. And for the time being, it is going to be free of charge for the next roughly 3 to 6 months. And as part of that, we want to solicit our users to help us with, suggesting improvements or areas of concentration for new features to add so that the offering can be improved moving forward. But so far, previously, ROCK has done a great job of offering you excellent LiDAR data in a 3D space, but there has been that, your LiDAR units are also collecting photos. So what can we do to take advantage of all that data that's been captured and allow you to incorporate into analyzing and understanding your sites? And so that's what our hope is with the new photogrammetry offering. So moving on, just a bit of an overview of what we're going to be going through in this webinar. We'll start by discussing, why are we offering photogrammetry, and then getting into ROCK's offering of photogrammetry, what your workflow would look like for data collection, data processing, and then data analysis. And then finally, we'll have some recommendations for using the new photogrammetry offering, the limitations associated with the photogrammetry offering, and then finally, a bit of a topic about moving forward as far as the photogrammetry offering in the future. I do want to let you know that members of the ROCK team are a part of this webinar, ready to answer your questions that come in via the chat or the comment window. So if you have those questions, feel free to answer them. The ROCK team is ready to provide you with your answers as quickly as possible. And then finally, after we've gone through the presentation, we do have 2 data sets that are available that we're going to do a bit of a demonstration of, show you some of that functionality, what everything looks like. So we're going to start, as I mentioned, with why photogrammetry. There is a limitation that an RGB point cloud does have. Looking at the image we have from one of our demo data sets of a substation, certainly the 3D features within the substation are visible. We can see the utility lines. We can see, roughly what features are taller than others, how all the utilities are connected. But because it is based on a point cloud, it sometimes is a bit more difficult to kind of make out the full coverage of some of the features, especially if they're suspended and thin. And so we do have that as part of why we wanted to do a photogrammetry offering. Also, sometimes people are just interested in a simple overhead view of the data. While it's great to get into the smaller details of understanding where you have, a curb and what the height of that curb is and so on and so forth, sometimes to convey information about your sites in the data set, you just need that large scale view from overhead. And that's what our photogrammetry offering is hoping to accomplish. Also, and as previously mentioned, your R3 Pro unit is up there capturing photos. We use it to create that RGB point cloud, but why not try and use it for something more? And so that's kind of some of the genesis behind why ROCK made an effort to offer photogrammetry within the ROCK cloud. And so getting into ROCK's offering currently, so I've got a screenshot from one of our demo data sites. And as you can see, it's showing the ortho photo over the area that was surveyed. We have the background kind of street view map that's in there. This ortho photo will be generated when you're processing the R3 Pro V2 data in ROCK Desktop. Right now, it's critical to note that to have an ortho photo generated and visible within ROCK Cloud, you do need to be collecting your photo and LiDAR data with the R3 Pro V2. So again, if you are interested in getting your current R3 Pro unit upgraded, please reach out to us and we will make sure that you are added to the list, understand the time frame and logistics involved with that upgrade. The 2D view that previously just had a base map and showed trajectory information and overall site location within your project is now going to display that ortho photo. So you have the ability to inspect it. And then again, with a single click over to the 3D view, you're now able to, you can then go back and forth between an ortho photo and the point cloud view in 3D for your data set. And then also within this, you can get your photo locations plotted over the ortho photo, and those photos can then be clicked on and further allow for further inspection within ROCK Cloud. So that's a new feature we're calling ROCK Inspect, where for, let's say, a rooftop or for some sort of geologic hazard analysis, something like that, you can really see the finer details within your data set and within the photos to truly get an understanding of your data set and your survey area. And so for data collection, something that's really nice about the ortho photo and photogrammetry option now offered by ROCK is that you don't need to be taking the time to adjust your mission parameters anything different than you've been doing in the past. We have listed here in this image are recommended mission parameters for flying with an M300 and M350 on the ROCK R3 Pro V2. General topography, you can still fly at about 120 meters with a 30% overlap up to speeds of about 6 meters per second. And you're going to get not just a high quality point cloud data set, but also a high quality ortho photo will be produced after the fact. As we get into areas where you might need a level of greater detail, such as survey grade topography or examining that substation like was seen in a previous example data set, you do want to fly lower and slower. But again, this isn't changing for what you would previously use with your R3 Pro. So again, you can just follow the existing R3 Pro workflow for data collection as it relates to your mission parameters, your calibration collection. So that's going to include the high-speed kinematic, the figure 8, not having that horizontal speed exceed 3 meters per second for your drone after collecting the second high-speed kinematic flight, still collecting base data that we use for our processing workflow, the incorporation of GCPs and checkpoints and getting them aligned, and then a 1 second time interval is good for data capture as well. I do want to also point out that the ROCK Pilot app is going to be one of your friends for flying missions with the ROCK R3 Pro V2. We just released an updated version of that application that's available through your ROCK Cloud page. And now it's offering you the ability to see data your point cloud data coming in real time on the remote controller. So really excited to see that and improve that functionality and offering for our customers. So again, the short of it, data capture, nothing is really changing if you're used to flying with an M300, M350 and using the ROCK Pilot app. Now for data processing, what's going to happen is when you're in ROCK Desktop following your workflow as far as editing trajectories or range gate, angle gate, when you get to the process final output steps, you have the ability to toggle on the generate orthomosaic option, which you can see in the bottom of the image on the left. You also can control the file name, the resolution. Obviously, by changing the resolution, that could change your processing time, so please be aware of that. But then your orthophoto and LiDAR point cloud are going to be generated at the same time. And then after being created, it's going to be uploaded. You can upload it to the ROCK Cloud with the rest of your data. What is really worth pointing out at this time is how quickly the orthophoto is also going to be generated along with your LiDAR point cloud. So there was a data set I was working on earlier in this week, and it's still on the order of minutes for getting that orthophoto generated along with the point cloud. So you're not looking at a significant added time to your processing workflow to get that orthophoto generated, which we're really proud of. The other aspect of that is the increased time associated with larger data sets. It's linear on data processing. So for example, if you had a data set with 200 photos and then another data set with 400 photos, you could expect roughly double the amount of time of processing, not more of an exponential increase in processing time with larger data sets. So that's something that we hope people really enjoy. But the images that you see on the right in this slide, that's going to be what you're going to see within ROCK Desktop after toggling on generate orthomosaic. You'll see that it's processing and colorizing your orthophoto and then uploading the project files to ROCK Cloud. You can see we've got the .tif there at the bottom. That would be the orthophoto. And so now moving on to data analysis. So the orthophoto that you're going to be seeing within ROCK is going to be from the nadir. So it's going to be straight down. What you can see in the image here is a rooftop where we've made a measurement of the roof area. And you can see, excuse me, for this example, you'll notice when we get to examining the data set that we flew for demo purposes, there's a rooftop with solar panels on it, and right next to it, there's a roof without solar panels. So maybe someone's thinking, what kind of an area do I have on the rooftop for adding solar panels for power generation? Well, using the new photogrammetry offering combined with your 3D point cloud, you can get a really accurate quantification of the area of that rooftop that would be available. So that's the example I have listed here. It looks like it's about almost 200 square meters for this roof. And you can see also it's showing the dimensions for the sides as well. We've got roughly 24 meters on one side and about 18 meters on the other. Please note that your measurements that are made in the 3D space will transfer over to 2D, but not vice versa. So, you probably want to start within the 3D view if you want to be going back and forth for your measurements in both spaces. And then moving on to data analysis within ROCK Cloud with your orthophoto and being able to go back and forth between the 3D view and the 2D view. So again, by being able to inspect the photos, we call that ROCK Inspect. You can now zoom in to the features that you see in the orthophoto and then select the photo. So in this case, it's going to be that green dot on the right side of the image on the left. You can then zoom in on the individual photo, really understand what you're seeing. And so for this example that I'm using as far as data analysis, I don't think I'm going to be, this isn't really a hot take that I imagine most people will disagree with, but potholes are pretty terrible. I don't like driving on roads with potholes. I hope people within this chat also don't like driving on roads with potholes, damaging vehicles, so on and so forth. And so what we can see here is that this pothole that's been filled with water in the survey area, again, the 3D view of the RGB point cloud may not really bring that feature out, or it may be hard to distinguish. But looking at it, the ortho photo in 2D and incorporating in the ROCK inspect functionality of being able to examine the photos, you're really able to see that pretty small pothole feature and get in and inspect it. And so what I've done is all the way in the bottom of the slide is I drew one of our height profile measurements through the 3D point cloud with our LiDAR data set. And from this, you can see that this pothole is roughly 4 inches deep and 6 feet long. Now, again, you're not going to be able to get this information just out of the ortho photo because, well, it's 2D, so you can't understand the depth or the length or the width of a pothole feature like this. However, then when you combine it with what you can see in the 3D view and inspect your elevations associated with it, that's where you can really bring out an understanding of this feature in three-dimensional space. I was doing some additional work within this data set, and you could also use the stockpile analysis to see, how much a true volume associated with this depression. So it's not necessarily just associated with, getting a pothole analysis, but it is maybe understanding depressions as far as whether it's for, water retention, flood retention, so on and so forth. So a lot of applications of being able to go back and forth between what you see in the 3D space and then what you're able to bring out in the ortho photo and by visually inspecting the photos. And so now, as we go on to our recommendations, really, and this is kind of going to apply for all of your surveys, but as you're planning your missions, we really want people to be thinking about what are the goals of the project, what will my final audience be for presenting this project and this data, and when do I need all of this by? And so by asking those questions, you can best plan for your survey mission, the processing, your coverage, and how much time you need for inspection of that data set. So it very much is the classic prior planning prevents poor performance. We think of that all the time. Probably everyone's been hearing that since high school. And so if you do take the time to consider what your overall goals are, who you're going to be presenting this information to, you're going to be able to kind of best inform your planning for the mission and how you want to focus on data capture. Also, that goes hand in hand with spending the time to analyze your results and use both the 2D and 3D viewers together. It's a simple toggle between the map view and the 3D view as that center image shows. It loads pretty quickly between the two of them. So you can kind of just go back and forth, see how do these features align? Am I seeing the right things here? What am I seeing in the 3D view that doesn't show up very well in the ortho photo and vice versa? And then finally, one of the main recommendations we have is that please make suggestions for how this offering can be improved for you and your colleagues. ROCK is, we feel that the best advocates for the improvements that can be made in future ROCK releases are current ROCK users. So please, for the suggestions that you may have or the feature requests, please feel free to send them to support@rockrobotic.com, or also take advantage of the ROCK community. Go in there and post and say, whether it's, hey, I found this a great new use of going back and forth between my 2D and 3D view with a data set collected with the R3 Pro V2, or even just post in there and say, it would be great for me to be able to have this new feature. And we'll get that submitted to our dev and engineering teams, and hopefully make those feature requests come to life. So now also with everything, there will be a level of limitations associated with it. And with this image, what I want to highlight is, so if we look at the image on the left and kind of from that large high overhead view, we can see the red lines, which are the trajectory for the survey, and the blue dots being the photos. And what you can see for that diagonal trajectory line is that the photos are spaced further apart. That's because that diagonal trajectory is going to be the high-speed kinematic flight flown as part of calibration at the start of the survey. And we see the four cars parked next to each other. They're in between two of the more standard survey lines for LiDAR and photogrammetry capture. But now if we zoom in to that, to the four cars, and we look at the image on the right, what we can see is a bit of an offset that is present. So the reason that offset is in there is because the information from that high-speed kinematic flight was included. It wasn't edited out during processing in ROCK Desktop. So, this is something that we still ask people to keep in mind. Just because it's a new improved offering with higher accuracy associated with it, it doesn't necessarily mean that less focus needs to be given to the mission parameters, processing the data, and analyzing the data to be seeing what you have. So that is something we ask that you are aware of. Still take the time to process and inspect your data after it's been captured. You will know your data the best. Also, right now, for the time being, you can only download your ortho photo in a .tiff format. However, and also in the WGS84 CRS that the dataset gets set up in. However, moving forward in the future, we do want to be able to offer the functionality to download the ortho photo in a reprojected CRS or other formats. So again, some of the limitations both associated with that you do need to appropriately process your data in ROCK Desktop, but also some of the data that information that's available via download as far as CRSs that it's in, and the file format that it's available. Moving forward, so ROCK has a webinar that is scheduled for tomorrow, starting at the same time as this webinar started today, to introduce our colorized SLAM offering. So that is also part of what we have with the R3 Pro V2. Also, moving forward, we're going to be offering our mobile mount, which you can see in the image on the left. That's our R3 Pro V2 mounted to a vehicle for data capture. Also, the orthophoto and photogrammetry offerings within ROCK Cloud. This is a trial period where the offering is free to users. And this is the time that we want your feedback. I can't stress this enough. The best way that ROCK is going to be improved is by its users telling us where we could be improving or functionality that we could be adding. So please, I hope you take that seriously. More than happy for support@rockrobotic.com be inundated with requests for features or feedback of how you are using the photogrammetry offering. Again, we are looking in the future to increase offerings with respect to file types, projections, etc., as it relates to our photogrammetry offering. And then incorporation of the functionality of the new Color Eye Slam and mobile mount offering. So again, just a reminder, if you haven't signed up for our webinar tomorrow in 23 and a half hours, I urge you to do so, because we've got some other really great new tools and solutions that are going to be available to ROCK users. And with that, we can get into a demonstration of some of our photogrammetry data. Before then, if if there have been any questions that have come in via chat, and they would be applicable to everyone, feel free to put them on the bottom screen. But otherwise, I can show off some of our demo data sets. And again, please feel free to keep those questions coming in. So what I'm going to switch to right now is our ROCK R3 Pro V2 demo with photogrammetry. And we are starting off here in the 2D view. So that's our map view right there. And again, we have the ability to change our background map, road, aerial with labels, and the ability to turn on and off the photos, your trajectory, and if you wanted to, you can turn off the ortho photo. If you do get zoomed out or zoomed in and you get a bit lost, you always have this reset view button that is available. So standard functionality, but what I'm going to do is we'll turn off the trajectory and we'll keep the rasters, we'll keep that raster in there. But what we do want to focus on is the improved colorization and everything associated with really bringing out the features of a corner. And so, with the data coming in from the nadir, really it's pretty impressive to see in here that, visually we have this corner and the sides of the building really crisp, really well defined in from that straight down, also with the truck right next to it. And again, coming in as we move over to the street, seeing these, what we have in here with the parking strips reminds me a lot of flying calibration flights. And then also, if we move down, we might be able to find my friend the pothole that I had previously shown. But we go through and we see that throughout the data set. We are seeing these, visually pretty fantastic corners, the vegetation that is growing next to, and in some cases on top of the buildings. It takes a moment to load, but again, we get in, we can see the, a nice outline of the solar panels, small breaks between them of the individual panels, which is pretty impressive. And then if we come over, we should be able to find some utility poles, which also, or excuse me, that might have been, oh, that's a person. I thought that might have been a road sign. But we can see from the photogrammetry offering a really crisp, very good overlain ortho photo. And then again, once we just quickly switch over to 3D with a single click of the button, we have the same sort of, we're seeing our trajectory, excuse me, we are seeing the photo location. And then if we do come down here, we can see our 3D model with the RGB. So, looking at it, the difference between, what we saw here with that, that corner of the building versus the pickup truck next to it, you're not losing much going between the RGB and the ortho photo. But again, this overhead with the RGB point cloud, it's difficult to make out some of the features. And if we come over here to our 2D view, it's a bit crisper, it's a bit nicer, it just gives you that overall aerial view of your survey area to understand some of the features and what's going on in there. So also, as I mentioned, with the photo viewer, you have the ability to come in here, click on a photo. So your green dot is going to be the photo that you selected. And then you get your information as far as the X, Y, Z. And you have the ability to still zoom in. And so this is where, again, not that it's everyone's favorite thing, but cracks in the pavement or potholes, things like that, you are able to come in and visually inspect it. You could see that potentially for a rooftop. Are there any areas of concern as far as in this roof for, cracks, seals, anything like that, obstructions, what is this wire doing, so on and so forth. So a really great functionality to come in there and just do visual inspections of photos in your area. And then if we come back here to the layers, we can reduce that in size to bring it back, have more of a view of our ortho photo. And then also, smaller functionality like being able to change the opacity, so on and so forth. But something that's going to be helpful is the measurement. So if we come up here to our measure tab, or excuse me, measure layer, this is where you can see that area 1. And so this was this was a measurement that was made in the 2D. And so that's where we can see we've got these dimensions in, and what you are able to do is, you have the ability to come in here and modify your measurements. This one's already been made. But you can see those dimensions, you can see the area, and because the offering includes this great ability to delineate your corners, you do have the ability to really get in there and get your measurements kind of spot on with the location that you want. And then, if you did want to make changes, you would save, and then you can come back and we can always extend to the full view. So that's got some of our measurements in 2D. But then when we come into 3D, what you'll notice is that if I come over to the measurements over here, so this was the previous example that I showed where it was the area for the rooftop that was next to the other roofs with solar panels. So what's our area if we really wanted to get in there and understand the solar offering for this rooftop? And now with the point cloud, what you're able to do is really come in and also get that inspection and tie your measurement to a unique point. And if you want to, let's say the RGB view isn't the best, you have the ability to come in. We can change intensity and adjust your ranges to really hone in on what the corner is and get your measurement exactly how you want it. So maybe here we can come in, align, and now this is where you need to be careful, is making sure that you get it to that point. And this is from someone who's been working with this functionality for the past week. Much like a lot of things within any sort of GIS software package, the more time you spend working in the package, the more proficient you're going to become at it. And so then we can come in change our views. And now also ensure that, we've got our measurement boundaries exactly where we want it. So we can make these adjustments and make sure that we're getting our measurements exactly right and taking advantage of that high accuracy offering from the new R3 Pro V2. Click Save. And then if we come back to that measurement, we'll get zoomed out, and now we can see we're at roughly 440 square meters for this rooftop. We can come back in and we're going to be changing from the intensity. We can go back to our RGB view. And if we need to, full extent. And then, again, the measurement functionality is still going to remain the same. So if you needed to, you can still come in and make unique point measurements. You can make distance measurements. You can make your height measurement. You have that existing functionality. And then if you go back into 2D, we can see that this measurement is still, it transferred over to our 2D view. So now we can come in and inspect it. And, again, it seemed like some minor tweaks, but that's right up on the edge of the rooftop. Maybe could have done a little bit more to bring it over on this point. But again, when you're dealing with data that's coming in that's this accurate, combining the ortho photo and the point cloud, you might need to make these types of tweaks to really get the most accurate areas or volumes calculated. And so once again, I'm going to come back out. This is our demo photogrammetry data set that we have with the R3 Pro V2. It's streets and buildings. But, for those of you who know Harrison of ROCK, that rarely is, one data set in a neighborhood going to be adequate for him. He's going to want to make sure that ROCK's new offerings are going to kind of work in a less than desirable or more difficult environment for complex 3D modeling and ortho photos. And so we've got another data set right here that's an example of the substation. Now, if you're saying this looks really familiar, well, that's because it was one of the slides that I had, one of the images on the slides earlier in the presentation. It was just offered in the 3D view with the R3 Pro. Harrison went out and captured it with the R3 Pro V2 so that we were able to come in and get the ortho photo generated for it. We do have an ortho photo, but before we look at the ortho photo and examine it, what I want everyone to spend some time and I want to show is that this is a really complex site with a lot of features to be modeled in 3D. So first off, we can see everything in the RGB point cloud. But, quickly, if we toggle it over to elevation, there is a lot going on here. There's suspended utility lines. There's, piles of materials. There's what look like houses or trailers. There's utility lines that are closer to the ground. We have vegetation. There's a nearby road. So this is a very complex site. Now it's great for 3D modeling like a LiDAR offering because that's what LiDAR is great for, 3D modeling. But when you get into photogrammetry where you're trying to, have everything come down to a really crisp 2D overhead view, this is a pretty complex site. And so, as I mentioned, Harrison really wanted to make sure that the photogrammetry offering was, really high quality for a site like this. So again, we'll just zoom in a bit. We can see all these utility lines at the substation. We've got pallets of who knows what over here. We've got the utility lines that are kind of horizontal to the ground, those that are at a 30 or a 40 some odd degree angle, going over to this, utility line pole. A lot going on here. We got a fence. So now what we're going to do, sorry about that. So now if we come over to the ortho photo, again, we've got our trajectory showing where we have data being captured. So full coverage of the substation. We've got all of our photos in there. Really nice grid pattern with uniform spacing, exactly what you'd want to generate a high quality ortho photo. And then we've got our opacity all the way on. And so what we're going to do is, from the full zoomed out extent, a lot of those utility lines might not be visible. That's because they're so thin and they're suspended. But as we zoom in and we allow everything time to refresh, we can start to see not just the utility lines, but also, the support braces and everything else that goes into the entirety of the infrastructure for this substation. And you're not really seeing a loss of clarity as you zoom in. There certainly are areas that you could go in and maybe nitpick about. You could say there might be some smearing as you get to the edge of a vertical face or a suspended item, like part of this transmission line. But if you look at the coverage of this concrete piling that is supporting the utilities at the substation, that's a really crisp and great ortho photo. Again, if we go back to this in the 3D RGB view, it can be a little bit difficult for you to get the exact view to maybe understand, just exactly what the coverage is or where that feature is. Or in this case, depending upon here it's, going through the middle, but if you change your view, it's cut off over on the side. And instead, this is just that, that vertical nadir ortho photo coming in, giving you the ability to see what your site looks like from the air, not in any sort of the point cloud format, just the ortho photo. And so again, it will take a moment to load, but as we come over here, just to turn everything back on, we are over in this area. You're getting towards the edge of data capture with the photos, which will always have the limitation of will always push the limitations of photogrammetry. Where you don't have that data coverage, you're going to lose the fidelity in your ortho photo. And as we zoom in here, it's, again, this is a vertical object that's, at least probably 25 or 20 meters tall. And you're still getting a really crisp understanding of that tower, but also what's going on near the tower with the walkways, the utility lines, and it's over in an area where you're starting to lose photo coverage. So that is a pretty exceptional offering from photogrammetry, kind of all things considered, with what the coverage looks like, what the feature is that is being put into your ortho photo, and just how complex the area is. So pretty remarkable. And then again, that's a, you are understanding what that rooftop looks like, the slope, that it kind of is that, upside down V shape, what you have next to it. I wouldn't go so far as to say you could use this to find someone's lost truck keys on a site, but the functionality that you're getting, but we can see a mannequin that's on site. That's pretty remarkable, but a bit odd and spooky for this site. I'm not sure if anyone ever noticed that, but the crispness of this ortho photo, given the complexity of the site that it was collected at, and the fact that it was collected along with a full LiDAR data set that's been modeled, and you're not having to wait, on the order of, 12 to 24 hours to get an ortho photo generated is pretty remarkable. So wanted to point all that out. And, at this point, we have just under 10 minutes. And so more than happy to address any questions that may have come in via chat that could use further explanation. If there are any good examples of, please feel free to put them into the bottom of the screen for all the users and attendees to see, and I can address them. So Mike has a question. What will be the photogrammetry deliverable files for customers? So right now, in deliverables, you have your .tif in the CRS. That's going to be the WGS84 based UTM zone CRS that is set up with the project. So for the time being, it's just going to be that TIFF file. But again, our hope as we continue to expand our photogrammetry solution is to have other file types and other CRSs, if you reproject into a state plane, to have that available as well. All right, moving on to Vince's question. Will data reprojection in ROCK Cloud also reproject the ortho so it can be exported in other coordinate systems projections? Again, that is something we are working on for a release very, very soon. So currently, no, but that is something that we should be releasing very soon. So please keep, that might be an announcement that we put up in ROCK Community or what's new, something like that in ROCK Cloud. Keep an eye out for those postings. So how do the orthos look over heavily vegetated areas, and are there any issues with processing? At this time, I'm not positive what type of heavily vegetated areas we may have done test demos on. But, we do have some of the vegetation that is visible right here for this demo. So we can see that we are getting, we are seeing the difference between, vegetation, it looks like without the green foliage and vegetation with the green foliage. I'm not sure if this would count as, heavy vegetation as far as a hillside that is completely covered with trees. Obviously, one of photogrammetry's limitations is vegetation. But also something to keep in mind is that one of the great reasons that, LiDAR has advanced how it is vegetation. It's able to penetrate through that vegetation. So again, you're going to have the ability to go back and forth between the ortho photo and the 3D LiDAR offering, and you can see just kind of what's going on with that dense vegetation. So there's not going to be too much of a worry about stitching when it comes to heavily vegetated areas with our photogrammetry option. All right, so Ben has a question. Can 2D and 3D be displayed on separate monitors? You'd probably just need to duplicate your tab in Windows Chrome, and then you can separate them, have one in 2D, one in 3D. Hopefully that is answering the question you asked there, Ben. What is the megapixels of current camera, and what GSD ground sampling distance can be achieved? So right now, I believe we have a 26 megapixel camera. And the actual GSD that can be achieved, I'm not, it looks like that is going to be roughly 1 centimeter. All right, another one from Vince. If I have a large area that requires multiple flights to cover it, is there a way to process them all in ROCK Desktop to create a single orthomosaic? This also falls into the not yet, but very soon as far as our photogrammetry solution. So, you still have that functionality within ROCK Cloud to upload multiple flights, where if you are flying with the R3 Pro V2, for all those flights, you'll get the ortho photo, and then you can merge them together in ROCK Cloud. So if you were to try and do that today, you could not create a merged ortho photo. But again, that is something we intend to offer very soon. So please keep an eye out for any announcements related to that functionality. Will there be simulation training in the academy? It would be great if there could be further clarification on the simulation training, but our ROCK Academy is something that we are continually building out and adding to as new features and functionalities become available. So within ROCK Academy, there definitely will be training videos associated with our photogrammetry solution and offering. Training simulation, I don't necessarily know, if it'll be something allowing you to go in and, grab a measurement within a demo data set and adjust it. But again, if you've seen any of Harrison's videos, he really spends the time to, you might not necessarily need your own simulation because Harrison does it for you in some of his videos as well. All right, so when using GCPs, are these added in ROCK Desktop now or in ROCK Cloud Processing? Is this, it's not going to change as far as the workflow. So your GCPs are going to be, this is where you're going to add your ground control points you would add it in ROCK Cloud. And so again, this is a bit of a difference between traditional photogrammetry and the ROCK Photogrammetry offering. So, kind of in traditional photogrammetry, you're capturing, 2D photos of a 3D world, and you're incorporating those ground control points to be used as just that control when generating your ortho photo and 3D model. In the case of ROCK, because we're starting with that 3D data set already and then going to a 2D ortho photo, you don't have to, you're not incorporating GCPs in the ortho photo processing like you would traditionally think of. We do need that base station location, and you want an ortho, to get everything accurate, but it's not we're not changing the workflow to generate the ortho photo like you would for traditional photogrammetry purposes, where you're setting out a set number of ground control points and surveying them in evenly distributed throughout your site, getting a topo high, topo low, so on and so forth. And with that, we're coming up on the hour. So I really want to finally take some time to thank everyone for attending this webinar, participating by asking questions. Again, we believe at ROCK that our users are going to be our best resources when helping us improve our solutions and offerings. So if you do have any recommendations, questions, comments, so on and so forth, please feel free to reach out to us and give us that feedback. Again, thank you for your time, and I hope everyone has a great day.
Ready to dive into the future of mapping? We've got a whole series of live webinars planned on rockrobotic.com where we'll deep dive into our products and services, showing you exactly how they're going to radically change your mapping projects. Don't miss it. Ready to dive into the future of mapping? We've got a whole series of live webinars planned on rockrobotic.com where we'll deep dive into our products and services, showing you exactly how they're going to radically change your mapping projects. Don't miss it. Ready to dive into the future of mapping?